Hi everyone. Today I am going to talk about static code analysis, which is one of the uh, very important process in source code analysis. So we have named the conversation as continuous code inspection with Sonar, simple that is CCI. Static code analysis is a process where we find it as a sub-process in a code review process. You might have heard of code review, which is one of the very important part of entire software development life cycle, where senior software engineers, senior technical specialists and tech leads are going to sit with other developers and review the code which has been written by different engineers and developers. So we used to perform this static code analysis at the phase of code review, and this is a very important phase in security development lifecycle as well. Static code analysis commonly refers to the running of static code analysis tools that attempt to highlight possible vulnerabilities within your source code. So we can write a source code and then we can put it into a tool which is capable of doing static code analysis, and the tool will provide you identified vulnerabilities, set of vulnerabilities, where you can think of fixing them to prevent them make a trouble at runtime. There are a few techniques that we need to know. So if you are trying to analyze the source code, there's one mechanism called taint analysis and a data flow analysis. If you look at the techniques, these techniques are often derived from compiler technologies, data flow analysis and also taint analysis. In data flow analysis, that is used to collect runtime information about data in software while it is in a static state. We are not going to run the source code. We will find out, we will analyze the code in a static state. In taint analysis, that attempts to identify variables that have been tainted with user controllable input that traces them to possible vulnerability or possible vulnerable functions. That's also known as a sink. If the tainted variable gets passed to a sink without first being sanitized, it is flagged as a vulnerability. There are certain quality requirements that we need to meet. So if you have a newly written code, that should be covered by a unit test. And if you have new method, they must not have complexity over a certain threshold. So we can find out the threshold by going through the given recommendations in standards. No cycles between packages should be introduced, and no code duplication should be added to the source code as well. So if you look at what is Sonar, it's a continuous inspection engine where it is capable of scanning the source code and provide quality related information. So it has information radiator of source code, quality information, dashboards, drill downs, charts, and it promotes transparency as well. Leverages continuous integration that requires a repeatable automated build. We can integrate this with Ant, Maven or Gradle, whatever the build framework that you follow. And there are two tools to look at. One is SonarCube and the other one is SonarLint. Sonar Cube is a complete solution where you can set up it as a cloud or else as a server, where you can plug your source codes into Sonar Cube and get your source code scanned, and at the same time it's capable of providing you certain reports. Sonar Lint is a small tool where the developers can get the benefit. You can install the Sonar Lint to your favorite integrated development environment and then scan your code at the time you write it. So that helps us to reduce vulnerabilities in future. At the development time, you can fix them before submitting it to the Sonar Cube server that you have. Right, we'll meet at the demonstration then. Thank you.